So we're going to calculate some properties here with the conditional distribution of y given a value of x. So in problem 4.3-17, we've got the marginal distribution of x is given to us as uniform on 0, 1, and the conditional distribution is given to us on uniform on 0 e to the x. The first part just asks us to find the conditional distribution, the conditional PDF of y given x is equal to little x. Well, since we're told that y is uniform on the interval from 0 to e to the x when we're given a value for x, it's pretty easy to calculate the conditional PDF here because we just need to do 1 over the difference of the endpoints, which in this case is e to the x. So the second part asks us to find the expected value of y given x. Again, this is pretty easy to do when we already know that we have a uniform distribution. We know how to calculate expected values of uniform distributions, add the endpoints, divide by 2. So in this case, we get e to the x over 2. You could have also done this directly by integrating your y over y times the PDF over the support. In this case, our support is 0 to e to the x, and then we would do the y times 1 over e to the x with respect to y, because this is just how we would do an expected value as usual, and go through the calculations, and you get the exact same thing. So you could have done it directly with definition of expected value or with our formula that we have for uniform distribution. Let's look at part D now, where it asks you to calculate the marginal PDF of y. So notice that we're given the marginal for x, we're given the conditional for y given x, and now we're trying to recover the marginal for the PDF of y. So the first thing we want to do is get the joint PDF, because once we have the joint PDF, we know how to get the marginal. So we know the marginal PDF for x is 1, because x is uniform on 0, 1. We already said we established what the conditional distribution was. So if we just multiply the marginal times the conditional, it recovers the joint distribution, which in this case is 1 over e to the x. Well, note that our support for this joint PDF is 0 less than y less than e to the x, because we know that the conditional for y given x was uniform on that interval, and our x's run from 0 to 1. Now, the tricky part to this problem when we do the marginal, of course, is that this is described as integrating with respect to y first and then integrating with respect to x. If we're going to calculate the marginal with respect of y, we're going to have to integrate with respect to x. So we're going to have to rearrange how we describe this region. So we notice it's a little bit more complicated. So we know that when 0 was less than y was less than, this should be 1 over e to the x. The bounds for x were for 0 to 1. Oh, sorry, I lied. This is let's look at the picture. Here's the picture. When we see that 0 is less than y is less than 1, so this region down here below the second red line, we notice the bounds for x are just from 0 to 1, because it's a rectangle at that part. However, if our y is from 1 to e, above this red line, we notice that the bounds for x are log y to 1. And again, that's represented by this top red line here. So notice at the top part of this region, we're hitting the curve, y equals e to the x, or x equals log y. The bottom part, we're just hitting these vertical lines, 0 and 1. So we've got a more complicated region to describe when we have to describe the x first and then the y's. So what this means for our marginal PDF is that it's going to be a piecewise defined function. So to find the first piece for the part where y is 0 to 1, our x bounds were 0 to 1. Integrating that, we would integrate our function e to the minus x, gives us minus e to the minus x, and so we just get 1 over 1 minus e. We'll plug in the endpoints of 0 and 1. The second piece, when we go from 1 to e for y, remember our bounds were log y to 1. So when we integrate that, same antiderivative, negative e to the negative x, plug in our top endpoint, plug in our bottom endpoint, and do some simplifying, we see that we get 1 over y minus 1 over e. So our marginal PDF, again, like I mentioned before, it's a piecewise defined function depending on whether it's between 0 and 1 or 1 to e. So for 0 to 1, we have 1 minus 1 over e, and for 1 to e, we have 1 over y minus 1 over e.